Okay, I think we're good to go. So after reading my data frame into, sorry, after reading my CSV into a data frame, I'm going to display the first five entries. And this is what our data set today looks like. If I remove dot head, I see that I have 20,718 rows across 10 columns. So essentially, our data set contains details about some music, some tracks available on YouTube and on Spotify. Okay, similarly, you can use dot tail to obtain the last few entries of your data set. Okay. You can use dot shape to display the number of rows against the number of columns. We've already verified this number. Dot columns is going to directly give you a list of columns. So here we have artist, track, album, the type of album, the number of views, likes, comments. As a Boolean variable, we know if the track is licensed or not, then we know if it's an official video or not, and then we have the stream count. Similarly, you can write dot index to know how many indices there are. Right now we have integers, so this is how you interpret it. It starts at 0, it stops at 20,718, and a step of 1 just means there is an increment of 1 after each index. Okay. To display the general information in your data frame, we use the command sampledata.info. We're going to study the details of how to use this, how to process this when we cover module 2, data cleaning. For now, it tells you how many non-null entries you have. Rather, it helps you understand how many missing entries you have, what is the type of the variable stored in each column. So apparently, artist was stored as strings. However, the data type at the backend, as we discussed in our last lecture as well, is actually an object. Then float 64 represents a number over here. Okay, with that, moving on, for our numerical attributes, we use the function .describe, which automatically filters out all the numeric attributes. In this case, it's just views, likes, comments, and streams, and then it prints the summary statistics of it, the count, the mean, the standard deviation, min, max, and all your quartiles. For non-numeric variables, you cannot use this function. However, info works, value counts works. It tells you the count of each unique instance in your given column. Similarly, n unique gives you the number of unique entries, and dot unique gives you the names of the unique entries. So with that, let's move further. Then for numerical attributes, what you can do is you can refer to the column, and then if you write dot min, dot mean, dot max, or dot count, you're going to obtain those properties directly. These are some functions in Pandas that are available for numerical attributes. However, I believe that min and max is going to work for your string operations as well. So similarly, if I want to get the sum of total comments, this is how I would do so. So the name of my data frame, then in square brackets, I refer to the column name, and then dot sum as my aggregation operator. So with that, we have looked at some basics of pandas, and we're going to move on to questions. This was just for a quick recap. My assumption is you guys have been through these things before as well. So we have a list of practice questions for simple ones and then slightly tougher ones. I'm going to use the same data frame. Okay, let's start with some basic filtering queries. So I'm going to move at a slightly faster pace. If you guys are stuck anywhere in between, feel free to stop me and ask any questions. So first you have to select the attributes of all songs by the artist Ed Sheeran. This is how we would do so. Data frame, and then if I write artist, double equal for comparison, and then I will give the name of the artist. And this is going to give me a Boolean series. It's not an array, it's a series, but generally we refer to it as an array as well, and it works. And I can directly refer this inside my data frame. And just like that, I have selected all the attributes, which means all columns, for the rows where the value of the artist is equal to Ed Sheeran. Are there any questions at this point? Okay, I think we're good to move on then. Similarly, if you have to select the top 10 entries of single type albums, so first I'm going to, of course, select album type. Think, yeah, that is the name. Double equals, and then I have the keyword single. It's going to give me a Boolean array or a Boolean series again. I will put it inside my data frame. Can anyone tell me how to refer to the first 10 entries now?
Like if you write head and in the brackets you write 10.
Perfect, excellent. So head and 10 will automatically give you the first 10 entries. What if I want to reset these indexes like 2, 6, 8, 1, 11? What if I want it to be 0 till 10? Can anyone tell me how to do that? Okay, so guys, for this you have dot reset index command. This is what that does for you. Okay, and then you can drop this index column as well, but we look at that later in further modules. With that, let's look at question number 3. Find all songs that have more than 10 million views. So I'm going to select data frame views and then greater than 10 million. I think that, yeah, that is 6 zeros. And that will give me a Boolean array. Then I can pass it to my data frame. But right now, I'm getting all the rows against which there are more than 10 million views. How do I select the name of only the track, for instance? Can someone tell me how do I select only the track for these rows? Okay, so your given result is a data frame. In your data frame, if I select track like that, it will give me a series with only the track names. If I pass track as a list, it will essentially give me a data frame with only tracks. And I think with that, let's move to question number 4, some basic Boolean operations. Let me see. Okay. So first you have to find all the songs that are licensed or that have an official video available. So I have my column name for licensed here and then one for official video here. So let's use those. So data frame licensed equals true. Okay, that's my first query. And then data frame official video equals true. Now I have two operations and I want to have an OR operator in between them. So in Pandas, this is used as your OR operator. And whenever you do that, you will essentially not get a Boolean array right now. You'll get an error because it's important to ensure whenever you have a query like this, that's a combination of other queries, square brackets, parentheses are a must. Otherwise, it fails. And then I can pass this Boolean array inside my data frame, and thus I obtain all the rows, 15,723 in total, against which the songs are licensed or that have an official video available. Similarly, I have another question over here. Okay, let's try this out. Get all tracks from albums where album type is album with more than 50 million streams. So that is how we would do so. Okay. Album type double equals album. That's going to give me one Boolean array. Then similarly, data frame views greater than, oh, it's streams, it's not views. Let's change that. And that is going to give me my, hold on, let's see what the issue is. So I think, yeah, we have stream as the keyword, not streams. And that's going to give me my second Boolean array. Essentially, I want to ensure that the album type is album and that they have more than 50 million streams. So I will use my AND operator, not my OR operator. So AND will be true only when both conditions are true. Then of course I have to include parentheses and I can pass it to my data frame. Hence I have obtained 7,756 rows. Moving on to the next question. Select all songs with more than 5 million views and fewer than 10,000 likes. So I will have views greater than 5 million and similarly likes less than 1 million. Can anyone tell me if I am looking for the AND operator in between these queries or the OR operator?
And operator.
AND operator. So hence I obtain 9,885 rows. Guys, are there any questions at this point? Okay, I have a question for you all afterwards. Focus on what we're doing over here. I am storing four results in variables A, B, C, and D. So I want you guys to take a minute here and think about what the type of each variable is, which will return a series and which will return a data frame. Okay, so I'm going to give you guys a minute to process this, and then when we display the types, we're going to look at the solution. Okay, I think that's enough. So let's start with A. Is A going to be a data frame or a series? Guys, please feel free to turn on your mics for this one. What am I expecting in A? Anyone? Okay, so A is going to give you a data frame. I'm going to comment out the rest of these so that we can view one solution at a time. It's going to give you a data frame. Essentially, here I am selecting a series, but the dot to frame command automatically converts my series to a data frame. See, otherwise it would have just been a series. Okay, moving on. What about B? Was anyone able to decipher this? Is B going to give me a series or a data frame?
Data frame, I guess.
Yeah, it will give you a data frame because essentially you're just passing a Boolean series to it. You're just passing it a Boolean array and then you're selecting all the rows. Hence, B is also a data frame. Okay, what about C?
A series.
A series, precisely. And what about D?
I guess this will give a data frame.
This will give a data frame. Now, would anyone like to volunteer and tell me why C gives you a series while D gives you a data frame? Essentially, it's just head and tail, right?
I guess probably because of the brackets. Like in the C, you have you're using one square bracket, and in the D one, you're using multiple
Absolutely,
square brackets.
absolutely. Yes, that is true. So here I'm just passing a single variable, a single string track. Here I'm passing an entire list of column names, although my list just contains one name, but it is a list. Hence, I get an entire data frame. With that, let's move on. From an MCQs and true false point of view, you guys should be able to very nicely distinguish between these two data structures. Okay, so we have a few indexing and slicing questions. I think locator and index locator can oftentimes be confusing for students. The best way to go about this is just to practice as much as you are able to. So let's look at question number 8. Use dot lock to select the first 5 rows and display only the artist track and views column. So df dot lock, and inside my lock, what will I have? The first 5 rows. So I think one way of going about this is to do that. Here I have my first 5 rows, and then you pass a list of columns, which I am already given over here. Artist, track, and views. And that is how I obtain the first 5 rows against only these 3 columns. If I want to use slicing instead, because I think it would be much more efficient, then can someone tell me if I should write 0 till 5 or if I should write 0 till 4? Oh, my bad. 0 till 4 or 0 till 3?
0 till 4.
0 till 4. And why is that so?
Because I remember like when we were like ma'am taught this ना तो उन्होंने बताया था कि इस function के अंदर you can write 4 instead of 3.
Yes, precisely. You can do that. So the thing is, whenever you use dot lock, it includes the starting and the ending index. It does not exclude either of them. So, for reference, for instance, if I do not enter the name of any given column, I will automatically select all columns. So 0 till 4 will include the 0th row and the 4th row. Instead, if I use iLock, it will not include the 4th row because generally in slicing, the final index is not included. So that is one key difference between these two to remember. Okay, with that, let's move on. Oh, yeah. Alternatively, if you had to do the exact same operation using iLock, okay, so up until this point, if I'm selecting all the columns, this is how I would do so. Of course, I would have 5 instead of 4, but that is how I would do so. But how will I select the columns? One way of going about it is to pass it a list of the indexes of those columns. So I know artist is at the 0th index, then I know track is at the first index, and then I know views is at the 0, 1, 2, 3, and 4th index. So that will work. But what if I want to reference them by name and I don't want, and suppose I do not know the index at which each is occurring, because in my data frame it could be on any index. In a new CSV of similar data, it could be on any index. So I'm going to, for your information, teach you guys an alternate way of doing that in iLog. See, we have an interesting function over here. Yeah, okay. We have an interesting function over here. You can ignore the x. It goes on till the 5th row in iLog. And then look at the list that I'm passing to it. Sample data dot columns. Now we know what sample data dot columns is going to give us. It gives you a list of columns, rather a list of columns in the form of indexes. Now if I write dot get location, and then I write the name of the column. Suppose I write artist, it's going to give me 0 because 0 is the index at which I have the name of the column artist. So that is how I can automatically obtain all the indexes in a list. And that is an alternative way of using iLock. Are there any questions at this point?
I wanted to ask what's the difference between lock and iLock?
Yeah, okay. So basically, when you're using lock, you are referencing on the basis of labels, and when you're using iLock, you are referencing on the basis of integers, only integers, such as if you would do so in a list. So I think one way of making this more clear is, let's see. So let's display the head, see what columns we have. What if I take the name of the album and set it as the index? Okay, I think we can do that. So df dot set index album. All right, now my index is album. And of course, we would either receive it here or we would do in place equals true. For now, let's keep it simple. Okay, now suppose I want to use dot locator. Using dot locator, I can directly give it the name of an album like that, and it will work because it goes to the indexes in the rows first. It iterates first over the row over here as the first parameter, and in the second parameter, it expects a list or a slice of column names. Now we're referring to it using labels. Suppose here I just passed demon days, so this was my result. Similarly, I passed the names of columns. I could just as well have an entire list over here. And hence it has filtered out only the albums that are, or only the indexes that are in this list. Similarly, you can use slicing as well, just like that. Starts over here, ends over here. It's not going to work right now because my labels are not unique. I think we've discussed that in class as well. And right now, I do not know for this particular data set which labels are unique, but if you have unique labels, this will work as well. Okay. Now let me show you what iLog will do differently. If I use index locator, my labels for rows or columns will no longer work. Rather, it will look at the indexes of these. Suppose all my indexes were stored in an array, in which case demon days would be at the 0th index of my array. Plastic beach would be on the first index of my array. So essentially, it expects the number of these indexes. And similarly for columns as well. So for columns, suppose the names of all my columns were stored in a list. Then artist would be at the 0th index of my list, track would be at the first index of my list, and so on and so forth. So that's exactly what it expects over here, the numbers of those indexes. I hope that answers your question.
Can you please tell what unique wali thing means?
Oh, yeah, of course. Okay, so let's look at one interesting thing over here. Suppose I do not set the index. Okay, and then this is what the head of my data frame looks like. So if I write df artist dot unique, see this is what I'm getting. And I suppose I want to check the length of this instead. So I have 2079 unique artists. Similarly, you can just do n unique and that works just as well. Let me show you. And if I remove the head out of this, then I know that in my data frame, I have 20,718 entries, but I only have 2079 unique artists. So That simply means if I give it the starting index as, for instance, for artist, I give it the starting index as gorillas, it's not going to know whether it starts here or it starts here, because the same thing occurs so many times across my data frame. So that is why whenever you're setting something as your index and you're using locator along with it, it always needs those labels to be unique. And that is generally the issue that we encounter. Let's suppose I had 0 1 2 3 4 5 4 and then 2 3 10. All right, and I am basically asking my locator operation to start from 2 and end at 10. Okay, suppose I wanted to start at 2, end at 10. 2 occurs over here and 2 occurs over here. I get an error because it doesn't really know which 2 to refer to as the starting point. Does that make sense?
Yes, yes, it does.
Okay, all right. I think let's move on then. This is a very important distinction to remember, by the way, for everyone. Okay, let's look at another question and let's try to determine which of these four will return a series and which will return a data frame. So at this point, again, I'm going to give you guys a few seconds to process this on your own. So I'm going to remove this over here and let's suppose that now this is what my data frame looks like. Okay, let's suppose again I have just these rows. Now my index is no longer artist or album. My index is just like starting at 0 and ending at 17,000 something, 20,000 something. So take a few minutes, let's discuss this. Okay, guys, I think that will be all. Let's start from A. What is the data type of A going to be? Would anyone like to answer this?
A data frame.
And let's look at that. Yep, it will be a data frame because essentially here you're just telling it to start from the start and end at the end, means include all rows. Here you're telling it to include all columns, so it's an entire data frame. What about B?
I'm not sure, but इसको edit नहीं दे देना चाहिए, like we are using zero for the reference rather than a label.
No, see, the thing is, if we had used this with lock, it would have given us an error. But we're using it with ilock, and ilock is expecting integer values. It's just expecting indexes in the form of integer. So it will not give us an error. In fact, let's
Okay.
try and print B. So this is what you get. It's actually a series. Gives it away, but it's going to be a series. It's going to be a series because essentially over here, you're just giving it the index of one particular row. Okay, if this was a list instead like this, then it would have been an entire data frame. Okay, what about C?
I guess series.
Let's check that out. So C gives you an entire data frame, and I'll tell you guys what the difference is. The difference is here I'm using just one integer, so it's going just to one row. Here I'm using a slice. Although the slice includes only one single instance, but whenever you use a slice, it calls the entire data frame instead of just a series. Okay, what about D?
Uh, can you show me the output for B and C?
For B and C, sure. So this is what B gives us. Okay. Essentially what happens is when you're just selecting one particular row, it converts the column names into the indexes and it uses the values of that row over here. That's just how iLog works. So this is to show you guys how it works. And this is the output for C. This is why C is giving you an entire data frame. I hope that makes sense. The
Yeah, got it.
difference is just in slicing. You guys have to remember that. Okay, guys, what about D? We're just left with D now. Here you're selecting all rows, but you're selecting
Data
just one
frame.
column. Okay, let's see. Or must be a network issue or something. It's loading. There you go. It gives you a series. So let's look at what D gives us. This is what that looks like. So I'm going to tell you guys something interesting now, and it's important to hold on to this. If you are giving one integer value, बेशक आप वो rows में दे रहे हैं or you're giving it in columns, it's always going to give you a series. If you're going to give slices in both rows and columns, only then you're going to get an entire data frame. Whether you're using .lock or you're using .ilock, both will work the same way in this regard. See here, I'm giving it slices in rows and columns. That's why it gives me a data frame. Here, although I'm giving it my columns in slices, but my rows are only in a single index. So it gives me a series. Here I'm giving both in slices, thus I get a data frame. Here, although I'm giving rows in slices, I'm giving my columns as just a single index. That's why I get a series. Is that clear? Are there any questions?
आई जस्ट वांटेड टू आस्क कि हम जब भी कोई कोड रन कर रहे होंगे हमें सीरीज तो चाहिए नहीं होगा आई गेस डेटा फ्रेम ही चाहिए हमें हमेशा
What kind of code are you talking about? Because you work with
लाइक
both
किसी भी
generally.
लाइक हम अगर डेटा सेट रन कर रहे हैं तो लाइक वी यूजुअली सी द टेबल्स जिस तरह अभी डेटा फ्रेम एक टेबल बना के देता है.
Yeah, you're absolutely right. Usually, when you have a data frame, generally, most data that you're working with, you're not just going to have one column, you're going to have multiple columns. So आपके पास data frames ही होंगे. But essentially, when you're working further down the line, when you're transforming data, when you're extracting useful information out of data, so you will find yourself to be working with series as well. It's important to be able to differentiate between the two.
Okay.
Okay, anything else, guys?
अब मैंने आपको कहना था कि जो बी है उसकी आउटपुट की लाइक मुझे समझ नहीं आ रही उसको मैं कैसे पिक्चर करूं.
Okay, let's print it. इसको हम print करके देख लेते हैं. Okay, now let me just show you something. Suppose I modify B like this. अब B की output देखते हैं. Do you understand the output of B right now? What's in front of us here?
यस यस.
So essentially,
यस
when I
दैट मेक्स
take
सेंस.
this slice and I change it to just the zeroth row, so what it does is कि इस row में जो आपकी सारी values हैं, it kind of transposes this matrix, and all of these column names become your indexes, and these become the values against your indexes. Like that. Now view it. See? These are your indexes, stream, official video, all column names are your indexes, and these are your values. I hope that makes sense.
ओके ओके आई गेट इट. यस यस थैंक यू.
Okay, perfect. Let's move on. Okay. There are some operations that I think I've introduced them इससे पहले भी, but it's important to just reiterate them quickly. Suppose you have to find the row with the maximum number of views. The first question is, how do you find the maximum number of views? And I think this we've covered before. So this is the maximum number of views across my entire data frame. Now I want to know the row that contains these maximum number of views. I'm going to write a simple filtering query. df views equals, and what am I trying to do here? Let's suppose I store this here. And this is going to give me a Boolean array. Now, if I pass this Boolean array to my data frame, this is what I get. Is that okay? So, guys, it's important to ensure, excuse me, it's important to ensure that you take this entire Boolean array and pass it over here, because it could also happen that there are multiple rows with the maximum number of views, in which case this will filter out all those views, all those rows, and you can do this directly over here instead of using a separate variable as well. So you should know how to filter on the basis of an aggregation operator as well. Essentially, I'm aggregating and then I'm filtering on the basis of that aggregated value, although it's not across groups. Similarly, suppose you have to find the total number of views for all tracks by I think this is the name of the artist. So df artist, and that is going to give me a Boolean array. See, this artist has multiple tracks inside my data frame. So if I pass this Boolean array to my data frame, this is what I get. I get all those rows where the artist is equal to sick legend. And then I want to count the total number of views. So now I will refer to my views column. See, now I get a series. And then if I use my aggregation operation sum, this is what I get. And everyone should know how to do that. Is that clear? Similarly, I can find the maximum number of views for this particular artist as well, the minimum number of views as well, and pretty much all of these will work. Okay, moving on to the next question. Extract the artist name and track name for any tracks with the least comments. So first I would want to find all the tracks with the least comments. Of course, I would look at comments equals df comments dot min. See, this will give me a Boolean array. So there are multiple such columns with the minimum number of comments. I think the minimum number of comments must probably be 0. So if I pass this Boolean array to my data frame, this is what I get. Like I told you guys, it is 0. That's why we have multiple instances, 499 such rows in total. Okay, now you have to find for this particular data frame, you have to find the artist name and the track name. So essentially, this is how we would do so. I'm going to use simple indexing. Let me show you guys something. Suppose I store this in a new data frame. Just to avoid any confusion, this is exactly what that looks like. Now I want to select a subset of columns for this data frame. So I want to select the artist name and I would like to select the name of the track. This is how I would do so. See, essentially, I stored it in a new data frame, but you can just as well do that directly on the same data frame. There's no harm in doing so. In which case, you don't need to initialize a new one to begin with. But sometimes a query like this can be overwhelming for students. Okay. Are there any
Just a question.
questions at this point? Yeah, go on.
अगर आप ये आर्टिस्ट ट्रैक को डबल ब्रैकेट्स में ना लिखें तो इट विल गिव अस अ सीरीज.
It will give us an error. Let me show you. See, now let's look at an error. Key error. Can anyone interpret this error for me? What is the problem here? Okay, let me show you guys an instance where this will work. See, it works like that, and it gives us a series. If I add another bracket, it gives us a data frame. Then why does it not work if I have two values instead of one? Because guys, I can only pass it either a list or I can pass it an entire I can pass it a single variable or I can pass it a list. If I have two variables, they have to be inside a list. Is that okay? Otherwise, it
Yeah,
kind
got it.
of thinks that artist comma track is a multi-index, which it isn't. Okay, I hope that answers your question. With that, let's move on to the next one. Sort the data frame by views in descending order. I think that's pretty straightforward. df dot sort values by equals views. But I think if we look at views, you will find that this is sorted in an ascending order by default. If you want to sort it in a descending order, can anyone tell me what we do in that scenario? It is sorted in an ascending order.
Ascending equals true कर देंगे.
Yeah, absolutely. We have to sort it in a descending order, so we're actually going to set it to false.
Oh yes, yes.
Yes, but you are right. And see, that is how we were able to do that. Now, if you look at view, so it's sorted in that particular order. Okay, let's look at our last two questions. Extract the top 10 most viewed songs. How would I do that? Would anyone like to contribute to this? Top 10 most viewed songs. Come on, people, whether you answer or not, try to have something worked out at your own ends, though. You're gonna find it really helpful.
I guess वो max function use करके head में brackets में 10 लिख देंगे.
No, no, the thing is कि max function के bracket में आप कुछ नहीं डाल सकते because max function gives you just one value.
आई गेस ये ऑलरेडी अरेंज हो गया अराउंड लाइक डिसेंडिंग में, तो हम इसको टेल अगर 10 करते हैं तो मोस्ट
Yes,
प्रोबेबली
that
हो
we
जाएंगे.
can do. So head या tail में आप 10 pass कर सकते हैं. So let's see, I have sorted it by views in descending order. Let's store this somewhere first. Sorted by views equals. Okay, and there we go. So that is how we were able to do so. Similarly, usme se phir you can just extract the names of the artist as well. Now let's look at question number 15. Extract only the artist names for the three least liked tracks. Again, I want you guys to take a few seconds and think about this. Iska kya procedure hoga? How do we do that?
Like if we arrange in an ascending order the artist के names के accordingly views को, and then we just display the head equals 3.
I'm sorry, could you come again?
अगर हम ascending order में arrange कर
Yeah,
दें artist के names को uh,
ठीक है. We're going to sort by what?
by the views.
By the views, yeah. Sort by views. Okay, in an
uh,
ascending order. Asha, there is a problem with this. Can anyone tell me the problem with this?
उससे सिर्फ artist का name मांगा हुआ I guess.
Yep, that is one problem with this. See, आपके पास artist का name भी आ गया. The thing is, you're finding the artist names for the three least liked tracks. So you're going to sort by likes instead. Other than that, you're absolutely right. Okay, and then if you want to extract the top three, you can simply do that. See, now we have a list of the top three artists only. Actually, the bottom three in terms of likes. Right now, you have it in the form of a series. So I'm going to tell you guys something useful. If you want to convert this to a list, this is how you do so. You'll find it useful later. I think in your assignment as well. ये dot to list का जो command है ये series को list में convert कर देता है. See, just like that. Now you have a list. You have an alternate command as well, actually. If I write list and add brackets around it, it will do the exact same thing. I hope that's clear.
मैंने आपसे पूछना था फर्स्ट असाइनमेंट कब रिलीज हो रही है?
First assignment key official release date is February 3rd, but we're trying to release it by 1st or 2nd, inshallah. Otherwise, 3rd at best, tak to it will definitely be released to you guys.
ओके ओके.
And then you'll have 2 weeks to finish the assignment. Essentially, it's not a very long assignment either. I think we're going to have around 25 questions focused on pandas here. I would recommend that everyone gives it their best shot. It's going to be lovely for practice.
एंड विल इट बी लाइक वेरी डिफिकल्ट?
There is going to be a spectrum of difficulty actually. Some questions will be simple, and then some questions will be of a medium difficulty level, and then, of course, there will be some tougher questions too.
ओके.
But overall, you guys will not find it very tough. Okay, is there anything else? Okay, so guys, I can see that we are a little short on time, but I have another notebook over here. Just maybe have a few more practice questions. Essentially, group by के कुछ questions हैं, and then just a brief look at pivot tables and string operations. So for those of you people who have to leave, you may feel free to do so later because I will be uploading this anyway. But I'm going to try and make this quick so that we can at least go through a few string operations right now. You're going to find it useful for your assignment. Okay, I'm using the exact same data set. I'm going to show you guys how to add a new column to your data set. Suppose you're adding a new column just to display the head so you remember what the data frame looked like. You'll always find this useful. Add a new column called engagement that calculates engagement by summing up likes and comments. So let's see how we create new columns. So df, the name of the, or let's suppose right now, I just write likes and this will give me a series. Similarly, if I write df comments, it will also give me a series. This is something amazing that you can do in pandas. If I add a plus sign in between, it will give me a series for which against each corresponding index, it will just add all the values. So if I take this series and suppose now I want to store it in a new row in my data frame, it's actually very simple. Engagement equals. And now if I display suppose the first 3 entries of my data frame. See, this is what that looks like. I hope that's simple enough. Is that okay? Let's move on. Similarly, you're adding a new column called official licensed video. That is true only if a video is licensed or it is, sorry, if it is official and is licensed. So df licensed. I hope you guys remember. This is another way to write your OR operation. Let me show you guys. We can do it the other way around as well. And then df official video. And this will give you a series. Oh, that's how you do OR. And then you can simply write df. This was the name of your new column equals. And now if I display the top 3 values of my data frame, hence I've added a new column over here. We have the drop column command as well. We're going to be testing it in the first programming assignment too. Essentially, we're hoping you guys will look up a lot of these things. So you simply write df.drop and then you write the name of the column. It's very simple. So suppose this is one column that I want to drop. Let me see what the problem is. You have to specify the axis in this command. Since it is across columns, we will specify 1 over here. Similarly, if I want to drop an entire list of columns, this is how I would do so. I would simply pass it as a list. Essentially, now if I print my data frame, I still have those columns. And here it's important to remember the in place command. I need to manually always set in place to true, otherwise it will not work the way that I want it to work.
जस्ट अ क्वेश्चन, ये इन प्लेस और एक्सेस क्या चीज़ें हैं?
Yeah, okay. So access जो है वो by default zero होता है, and zero access means it's going to iterate over the rows of your data frame. When you set the access to 1, it iterates over the names of columns instead. ठीक है, so that is the first thing. Access pandas की और भी बहुत commands में use होता है. And then in place is something that you use to make sure that your original data frame is modified. In place is always false by default, in which case आपके data frame में कोई modification नहीं होती, rather it returns a data frame with the modifications. So then you have to receive it in your data frame. I hope that's okay.
या ओके.
So guys, abhi error aa raha hai because I've already removed these two. So now I'm trying to remove them again. So let's not let that puzzle us and let's move on. Okay, I'm not going to go over the sorting functions again because we've covered this already. Oh, one important thing though, if you want to sort by two values, this is how you do so. You have to pass a list to by. Now, first I want to sort by artist, and then for each artist I want to sort by views. This is how I would do so. Other than that, I'm going to leave some things for you, but it's very important that we go over string operations. String operations are very useful. Find and display all tracks where the track name starts with the letter S. So if I do that, I'm going to get a series, right? Now, if I check the type, then for each given value, it is not essentially a string, but it is an object. That is just how Pandas treats strings by default. When I want to convert it from an object, see for instance, let me remind you all, if you press df.info, see for artist, the data type is given as object, even though I know my artists are all strings. So this is just how Pandas stores strings by default generally. So the first thing that I want to do to perform any operation is to convert these objects to strings, for which the command is very simple, .str, and that it just works that way. Now I have my artist stored as strings. I want to have this printed here. So .str, and then you have some very useful string operations. Like let's suppose for our numerical columns, you would simply do min or max. For instance, you had data frame likes, and you would directly call an operation such as min, such as max, or such as mean. For string operations, you have a different list of functions. For instance, len. Len will give you the length of all the strings. All right, it will give you the length of all the strings. I forgot to add parentheses to this first. Similarly, well, we already know about max and min, but suppose we have some other interesting operations. So I want to get all the tracks where the name starts with S. So I simply have dot starts with, and then I can specify S. What does it give me now? It gives me a Boolean array, and we know very well how to use a Boolean array, just like that. Hence, I have filtered out all the rows over here where my track name begins with S. Are there any questions at this point? I'm going to show you guys something fascinating. Similarly, you have ends with as well. It's written as twice. Similarly, you have contains as well. So for each string, it will check if it contains this letter. Similarly, you have .len as well. So for instance, .len is greater than 20 characters. So now it's going to filter out all the tracks for which the names are of a length that are greater than 20 characters. So you're going to find string operations to be very useful as well. Now, suppose I want to create a new column. I'm just going to display the first three rows so that we know what our data frame looked like. Suppose I want to create a new column called track length that stores the length of each track name, and I want to display the first five rows. Who can tell me voluntarily how we would do that? How can we do this? Using the same string operations that we've studied. Okay, I'm going to do this over here. So df track length equals, and then df track dot str dot len, and that is simply how I would do so. Now, if you look at your data frame, here you have a track length column introduced automatically. See, the only new thing is .str. This is something you have to add. Similarly, if you have to find the tracks that contain a certain substring in their names, then you would do track .str dot contains, and in contains I would just pass this. So it will automatically look for that substring and it will return to you a Boolean array. When I pass the Boolean array to my data frame, this is what I get. See, you can clearly see that this word is visible across all track names now. Are there any questions at this point as far as string operations are concerned? Okay, all right, let's move on then. So then we have a few basic custom functions, which we've already been over to. Suppose now you're creating a custom function that will characterize the count of views into low, high, or medium based on certain defined thresholds. So first I'm going to define my custom function. Suppose I call it get view rating, okay? And then of course I'm going to pass it one given value at a time. If my value is greater than, I think that's 10 million, or rather it's 1 billion, then I would want to return high. Similarly, if my value is greater than or equal to this number and less than this number, then I would want to return medium. And of course, if it's even lower than that, then I would want to return low. Up until now, I have just created a custom function. If you want to apply this custom function, you use the dot apply keyword, which we've studied. So right now, I would want to apply this on my column of views. Df views dot apply, and then you just pass it the name of the function. See, and this is what I get. Now, there is one last thing to do. I want to store this series in another column in my data frame. See, apply this function to create a new column called view category. And now if I view the first few rows of my data frame, here I have introduced view category. Okay, are there any questions at this point? Okay, let's move on. Similarly, there's another practice question over here which classifies a track as highly engaged if the sum of its likes and comments exceeds 50,000. Then you're going to apply this to the entire data frame and count the number of highly engaged tracks. So essentially, now the function that we're defining is not going to be applied to each row, rather, it's going to be applied to, sorry, not to each value in a column, but rather to an entire row, which means we'll have to switch the axis. So let's suppose I call my function check engagement. I'm going to pass it an entire row, and this is what it will return. If, so I will get the likes, I will get the comments, I will add those two things. So if the sum of these two is greater than 50,000, then I would want to return highly engaged. Otherwise, I would want to return, suppose I say not highly engaged. Now, essentially, I apply it the exact same way. So df, now suppose I want to introduce a new row, highly engaged or not, equals df. Now I'm going to call this function on my entire data frame, and then you just pass the name of the function. But I'm going to get an error right now. And I get an error because I've not specified the axis. Now I'm not iterating over just a single column, rather an entire data frame. In which case, as discussed in class already, you always have to specify that the axis is now 1. You're going over the columns instead. So now if I display the first few values, this is where my new column is. With that, let's move on to some basic grouping and aggregation questions. So first, you're going to group the data by album type and calculate the average views for each type. Then you're going to store the result in a data frame. Before storing it, let's split our question across parts and start with just grouping. So df.group by, then by equals, or rather you can directly specify the name, album type. Hence, I obtain a data frame group by object, which is just a group of data frames. So if I display the groups, that is what, oh, or rather, I would have to store it somewhere before displaying these. And then I have to apply an aggregation operation to it. So suppose I actually want to use this on a particular series instead. So I get a series group by object. You can use views over here or you can use views over here. It will give you the exact same result. Okay, dot, and then I have my aggregation operation, which is mean in this case. Oh, you're actually going to have to refer to mean in the NumPy library, np.mean. Let me see what the problem is. Key error album type. Let's see, maybe we're doing something wrong. Okay, let me look into this and get back to you guys on this. I don't understand right now what the problem is, but let me definitely look into it. Similarly, we have a few more grouping queries. I'm going to leave some of these for you guys to practice. Okay, and then let's move on towards lambda functions. Now, I hope you all remember that lambda functions are basically just simple one-line functions for which you do not have a name. You directly call these using dot apply or using dot filter, and it's automatically called for every single row or for every single column in your data frame, depending on what you're calling it for. So suppose you want to scale the views and likes column. So suppose you want to create a new column, views in millions, that simply takes the views and divides it by 1 million. And then you can use a lambda function for any other column as well. So I will do df views in millions equals, and I want to give it a series. So df views dot, I will call dot apply, and I will define a lambda function over here. When I write lambda x, it means every single view inside this column. And then I want to return x divided by 1 million. Now, if I display the first three rows, this is what I have been able to introduce. Okay, with that, let's move on. Okay, I'm going to leave some of these for you guys to practice, and I'm going to move on to a slightly tougher question. For each album type, find the track with the highest likes. Display the album type, track, likes, and artist for these tracks. You're going to use group by to group by the album type, and then you're going to use apply to find the track with the maximum likes. So let's see. The only important thing that I wanted to introduce over here was dot idx max and what it does. So let's suppose I go inside my data frame and I do that. So what exactly is this operation doing for me? If I simply write df likes dot max, or let's suppose I get the row of the data frame for which my likes are equal to max. This is what the particular row of the data frame is where I have the maximum number of likes. And this is the ID of that row, the index of that row, 1147. So if I directly write, if I could just as well refer to index over here, and it will give me 1147. Or I could write df likes dot idx max, which will give me the index where the likes are maximum. I think similarly you have idx min as well, which is going to be very useful. So here what I want to do is I want to write df dot group by, and I want to group by album type. All right. And then what I want to do is for each group, I want to apply this function. And this is what I've been able to obtain. Let's look at this. So I have three album types: album, compilation, and single. Against each album type, I went to the particular instance where my likes were maximum. So where is it? Yep, here are my likes. The maximum number of likes across album were this number, and then I have those for compilation and for single. And then it essentially gave me the entire row or the list of rows. In this case, it's just one row, so it gave me the entire row where the likes were the maximum for each album type. This essentially solves one question given to you guys as part of the case study in the last lecture as well. I don't think it was part of the case study actually, where we're looking at the elections data frame. And when you directly use group by, and then let's suppose I do group by, and then I want to do likes dot max, I get the maximum number of likes. If I remove likes and then I do dot max, it gives me the maximum value of artist, the maximum value of track, the maximum value of album, and then the maximum value individually across every single column for each kind of album type. But these values are not corresponding to each other. Similarly, for elections in one particular instance, we got Obama in 2016 with a maximum percentage of votes. However, those values were not corresponding to each other, in which case you will be using IDX max in this way. You have other ways of going about it too, such as the first operator. I'm not going to go over it right now, but that's definitely something you can look into as well. So IDX max is going to prove to be helpful over here. Now I'm getting exactly the corresponding row against which the number of likes are maximum. I'm going to leave this for you guys to explore at your own ends now, and I'm going to skip over to merging because this is important. We're going to use this in the assignment as well. And let me just show you the new data frame that we are creating. So I've created a particular data frame with an artist and with a country. And let's suppose now I have another data frame, which is my, of course, I have my original data frame as well, which looked like this. Suppose I print only the first two rows right now. See? So in my original data frame, I have 10 columns and I think I have over 20,000 rows. In my new data frame, I have just two rows and I have two columns. If I want to merge these two data frames, you're always able to do so on the basis of one common column that exists between them, kind of the way that you would do in SQL when you study database systems. So it's the same kind of merging. Pandas allows you to do that too. Now, my first data frame, artist details, contains artist and country. My next data frame contains 10 rows, but it does not contain the countries over here for each artist. So if I essentially merge these two data frames on the basis of artist, where the artist name is the same as each other, then I will essentially get a new column, which is country. Now, there are three different kinds of merging that you can do. I'm not going to go into the depth of each merging. Essentially, the way that you do inner joins, outer joins, and then, of course, left and right inner and left and right outer joins, we have all of those available in Pandas. Right now, I'm just going to show you how to do an inner join, and then you can modify the how parameter and experiment with this on your own. So the command is pd.merge. Inside your pd.merge command, you just add the names of both data frames. I have df and then I have artist details. Then your next parameter is on, where you're specifying the name of the common column on which you want to merge them. And then you're specifying how. This is what I obtained as a result. So what inner join did was it dropped all the rows where the artist value did not exist in my other data frame. And this is what I've obtained as a result. On that note, we will be concluding this session. I'm going to share these notebooks with you guys. On that note, hold on, where is it? Yep. Okay, I'm going to share these notebooks with you guys. And next week, I will try and hold a brief session where we will go over any problems that you've encountered in these two.